Hi, everyone. Welcome to the 2021 Southeast Regional Fruit and Vegetable Conference. I'd like to thank you for signing up and attending this year's virtual conference. You'll be attending the Strawberry Educational Conference. My name is Zach Snipes. I'm a County Extension Agent for Clemson Cooperative Extension Service. And today I'll be the moderator for this event. A couple of housekeeping things before we begin. Pesticide credits are available for a lot of these talks. You'll find the Pesticide CEU guide as well as the CCA credits located under the Event Resources tab. There you will find the list of approved presentations, as different presentations carry different weights. You'll find the participating states and the number of credits for each talk. Only available registered attendees will be available. CCH or CEU credits will be available to registered attendees. They will only be available during the live event. You can go back and watch these at a later time, but you will not receive pesticide credits for that. So the CEU process, you must do this every time. So you have to sign in and sign out. To sign in at the very beginning of the talk, like right now, you would go to the audience chat box, put your first name, your last name, and the state. And at the end of the talk, we'll remind you, and you're going to sign out. You do the same thing. You put your first name, your last name, and your state. And that kind of ensures us that at least you were there at the beginning and the end, and hopefully you were there during the middle. So you have to do that for every single webinar, every single talk you go through. Now, you have to do one more thing in order to get pesticide credits, but you only have to do this once for the entire conference. You have to complete the pesticide CEU registration. That can be found under the Event Resources tab. And again, you only have to do this one time. This presentation is pre-recorded to reduce technical difficulties. However, we will be answering your questions live at the end of this presentation. Please, if you have a question, a thought, anything that pops in your head, write it down in the questions box and press send, and we'll get to those at the end. We'd like to thank our 2021 SC Regional Fruit and Vegetable Conference sponsors and exhibitors. Please make sure you visit the virtual trade show and the featured products pavilion. These guys are our sponsors, and we want to show them a lot of love. So go visit them and check them out. My favorite thing to do at a conference is network. However, this year networking is a little bit different, but we have set aside a space and a time. We're having morning coffee chats beginning at 8:15 every morning, and then evening reception and networks begin at 5 p.m. every day. So be sure to go in there, hang out, meet some of the researchers, the extension agents, the industry folks, the exhibitors. We're all hanging out in there. So without further ado, I would like to welcome our next speaker. Is Dr. Natalia Peres from the University of Florida. She works at the Gulf Coast Research Center. She works mostly on strawberry diseases, which is a good thing because we got a lot of diseases in the South where it's hot and humid. And she did tell me her favorite disease was Cultivar. So that's a good disease to be familiar with in the Southeast. She is responsible for the diagnostic clinic at the Gulf Coast and Research Center. And today she's going to be telling us about, unfortunately, a new disease that has come in and kind of taken us all by storm, and we all have our eyes on it. So without further ado, Dr. Natalia Peres.
All right. Thank you, Zach, for the introduction, and thank you for the invitation to speak to you all today. So as Zach mentioned, I'll be talking today about this new disease that's been affecting Florida strawberry fields. Is caused by a fungus, Neopestalotiopsis. I know it's a mouthful there. I'd like to acknowledge a few people in my group who have done a lot of the work I'll be presenting here. In particular, Juliana Baggio and Nani Wang, they're research assistants in the program. And Dr. Jim Murley used to run our diagnostic clinic, has recently retired, but he was the first one to identify this disease in the field. So the pathogen is actually not new to strawberry. Pistolotia longicella has been reported for many years to cause fruit rot. And that's basically the same genus or the same fungus we're talking about today. It's just the name has changed quite a bit over the years. The taxonomy is confusing, but it's the same thing that's reported in the Companion of Strawberry Diseases, and it had been reported in Florida back in the early 70s by pathologists at the time, Dr. Charlie Howard. More recently, there are several reports on different parts of the world, in Europe, in Asia, and the Americas, but mainly of problems with ground and root rot establishment in plants that are weak or stunted for some reason. And those reports, they've been describing as caused by Neopestalotiopsis clavispora or Pestalotopsis clavispora, and that's because the taxonomy of this group is a mess, and we'll talk a little bit more about that later on. But all those different names, just keep in mind as we move forward, is basically the same thing. We're talking about the same fungus, Pestalotia, Pestalotopsis, and Neopestalotiopsis. It's just changes in the taxonomy. What is really new in this case is the aggressiveness of the disease we're seeing in Florida. In general, this group of fungi, Pestalotopsis or Neopestalotiopsis, is considered a weak pathogen. It's more likely to be secondary fungus that will attack plants that are weak for some reason or for some stress. But that's definitely not the case of what you're seeing in Florida. So, in pictures you see here, the disease starts as some leaf spots, some common leaf spots, but it develops very quickly and to take a significant portion of the leaves, and eventually it produces a lot of spores on those leaves, and it can blight a significant part of the leaf. This spot, especially under severe weather conditions, develops very quickly to blight a lot of leaves, and all the leaves that you can see in the picture in the middle were blighted to this disease. If the new growth, if the weather conditions are not favorable, will come up clean, but all the blighted leaves were affected by this disease. It can eventually take all the leaves of the plant and make into the ground and kill the plant, as you see on the picture on the right side. And here's an overview of some fields that were severely affected in the past 2 seasons in Florida. It looks pretty devastating, and almost looks like somebody came with a torch and burned all those plants, the amount of dead foliage that you see. In all those fields, we also have a lot of fruit rot. They will move from the leaves to the fruit. The initial symptoms are very similar to anthracnose, to my favorite pathogen, as Jack mentioned earlier, Colitotricum. In this case, Colitotricum acutatum causes anthracnose fruit rot. And like I said, the initial symptoms are very similar, but once the disease develops and starts sporulating at the end, the spores for the Pestalotopsis are darker, as you see in the pictures towards the right side of the slides. The spores, the conidia, are very distinct, though. So if somebody has a microscope and could look at the spores, they are very distinct and very easy to identify if it's Colitotricum or Pestalotopsis. This disease problem was all over the news the past year to the point that it was causing even more harm than the harm in the fields, because it was bad press for our growers to the point that they did not want to talk about this anymore. There are several other leaf spots that may be confused with this one, and we were getting a lot of samples in the clinic at the time and right now this season, just because every leaf spot now, our growers are worried that it could be this one. And usually our growers were not particularly concerned about the common leaf spots that you see in the screen here, because they're much more easily controlled and not as aggressive. Leaf scorch and common leaf spot that you see on those pictures caused by Mycosphera and Marsolina, different fungi. They can usually be distinguished by their center of the lesions. They're more tan, and the outer side of the lesions are darker than what you would see with Neopestalotiopsis. Marsolina spots are also, or leaf scorch, they're small, much smaller than what you see with Pestalotiopsis. Phomopsis leaf blight it's another one that could be confused, but I think those are actually not the most confusing ones. The most confused to me would be, this one, leaf blotch and Cercospora leaf spot. Those can really trick even somebody with experience in diagnosis, because their initial symptoms are very similar, and until you can see spores in the center of the lesions, it's very hard to differentiate those from the Pestalotiopsis, which is the bad one. Just a little timeline here on this slide on when this problem started, when we found for the first time in Florida. So back in the 2018-19 season, we received a few samples in the clinic, only 12 samples, and they're all coming from 5 different farms. It was pretty devastating for those 5 growers, but it was only those 5 farms that had that season. And the common link at that time was the nursery source for those plants, which was nursery in North Carolina. In the following season, which was last season, the 1920 season, we saw a significant higher number of samples, close to 50, and a significant number of farms, more than 20 farms. Early in the season, it was clear to see the link again with the nursery source, and it was most of the samples were from the same nursery in North Carolina, as well as a nursery in Canada that got plant stock from North Carolina. But after we had severe weather conditions in late December, the disease quickly spread to other fields that were close to those that were initially affected, and which really show how aggressive and quick the disease could move to other fields. We are now still at the early stages of our 2021 season, and I have already received close to 60 samples, so more than the whole season last year, and from over 20 farms. So what we're seeing this season is a bit different than what we've seen in the past 2 seasons, that we can't really see that link with nursery source as much anymore. What we see is that mostly fields that had the disease last season have it again this season, which kind of indicates that, unfortunately, it looks like the pathogen survived in our fields between seasons. So a little bit about the spread. The disease is usually spread by water. This group of fungus is spread by water, which we give plenty of it at the beginning of the season when we're trying to establish the plants with overhead irrigation, as well as rain, and it's been particularly bad when we had the hurricane type of storms in Florida. It seems to move the pathogen very far. And it's very explosive too after we have this prolonged periods of wetness with rain followed by overcast weather. Symptoms usually start showing up after only 5 days on the leaves. So we also know now that the disease is favored by warm temperatures, both for the growth and sporulation. So temperatures above 50 the fungus will grow, the ideal being close to 70, 77. So it does like more on the warm side. But for sporulation, it's really not until you're close to 60 when it starts sporulating, and under warm temperatures like 86, you see on the graph on the bottom, is when it sporulates the most. So it really likes wet and warm, which is what we usually have in Florida. And that's pretty much what happened in December last year, December 2019. We had a period of 2 weeks where it was just wet, not a lot of rain, not an amount, but it was just like raining a little bit every day, and overcast and cloud, and it's just wet all the time. And after those 2 weeks, a lot of the fields that had plants that were infected early came infected from the nursery, look like this. So again, it almost looks like somebody came with a torch and start burning those leaves. It's just very aggressive and very quick. So you saw on the previous slide, the period when that disease, the wetness period started was December 14. Those pictures are from when I was visiting fields around December 29, December 30. So just really a week after we had the conditions, the fields were significantly affected already. So moving forward to this season where we are, early in November, on November 10, 11, and 12, we had the Eta tropical storm going through our area, and which brought about 6 inches of rain. Winds are 55 miles per hour. And again, it moved the disease to fields that were not previously affected. After that, we had another couple of days when conditions were conducive, and it has since calmed. The weather has been less favorable in the past few weeks. But again, just another picture just after about 10 days after that Eta tropical storm. Those are some pictures from plots in our field trials, 2 different cultivars that were effective and just very, very quick. Those plants were inoculated early during the establishment period, so they did have inoculum, but it just took the 2-3 days of the storm to really spread all over. So what we have learned so far is that what we are seeing, we have confirmed what we suspect, that basically this Neopestalotiopsis, the species that we see now that's affecting Florida fields, is distinct from what had been reported before. So basically what this slide shows is that the bottom of the slide with all the green numbers are isolates that were recovered in the past 2 seasons when we have this problem. Everything in the blue box above were isolates from either from previous years in Florida, previous seasons, or from other areas that are reporting problems with Neopestalotiopsis, like in Mexico, Spain, Australia, Egypt, and Israel. So according to the new classification, everything that is in the blue box, the correct taxonomy should be Neopestalotiopsis rosei, not Clavispora or Pestalotiopsis clavispora, like it's being reported in some of those actually reports from those areas. The correct taxonomy is Neopestalotiopsis rosei. But what is affecting us is really a different species that we didn't give a name yet, but it's definitely distinct. The morphology is also slightly distinct. That's the picture with the plates, but it's not as easy to differentiate there. But one thing I want to point out on this slide is where I have a arrow at the beginning of the green blocks. It's an isolate that we recover in North Carolina, right next to the strawberry field that where the problem started. It was a rhododendron plant that we recovered Neopestalotiopsis from it, and it was basically identical to the strawberry isolates that we are finding now. So we hypothesized that maybe the disease started in rhododendron in this area in North Carolina and moved to the strawberry plants. During that summer of 2018, when the disease first started, there was a hurricane that went through the area and might have moved this pathogen from rhododendron to strawberries. So that's what we've been speculating, but it's definitely different than what we've seen before. And we confirmed that also by showing that it is more aggressive. So what you see in this slide on the graph on the left is for disease incidence on fruit. So when we inoculate fruit with isolates that were from Neopestalotiopsis rosei, those are the light bars, we got a lot less disease than when we inoculate with isolates from the new outbreak, which would be the darker orange. Same thing for leaves. When we inoculate with the older isolates, they were just not as aggressive on the leaves. They do cause disease, and the symptom is basically identical. You cannot distinguish by symptoms. The difference is really how much symptoms you get. So with the new isolates, you just get a lot more symptoms. We also shown that this new species sporulates a lot more than the old one under favorable conditions. And that's probably what makes it so aggressive. It just produces a lot more spore on those leaves, on the fruit, and those spores are easily moved when we get rain or when we use overhead irrigation. We've been looking at cultivars, and there are definitely differences among cultivars, but bottom line is that everything is susceptible. At least the cultivars that were looked last year in Florida, those are basically our UF cultivars, in case you're not familiar with, and it might be different in some of the other production areas in the Southeast. But the difference is really the timing of the season when we're taking those ratings, if the weather, but bottom line is if the weather conditions are conducive, they're all susceptible. This season, we expand that trial quite a bit. Last year, we looked at only those 6 cultivars. This year, we have 21 treatments in the field right now. 9 of those are commercial UF cultivars that were still being grown or were grown in the past. And we also have 12 advanced selections from the breeding program. And again, and unfortunately, we do see differences, but they're all susceptible. We also have another trial where we're looking at wild types, strawberry wild types. And in that trial, we have 16 sessions. And that's the good news there. There's a light at the end of the tunnel. About 8 of those are looking resistant to the point where we don't see a single lesion on those leaves. But that's a long-term project to make crosses with those wild types and incorporate that resistance. So it's not something we can consider as a management alternative for the near future. Here are just some top shots from this season, comparing 3 different cultivars. As I mentioned, we do see differences, and especially with the cultivars that might not be as vigorous, like Beauty. It's usually a compact plant, not a lot of leaves, and when you lose a few, it just looks pretty bad. The one on the bottom is an advanced selection that seems to do a little bit better. It's a bigger plant, but if you look close, there's still quite a bit of symptoms, but because it's a bigger plant, it doesn't seem as affected. As far as fungicide trials or for management of the disease, the data I'm showing here is from the trials last year, because the current trials are still ongoing. And basically, we have only a few fungicides that are effective. And they're, I wouldn't say they're highly effective, but they do suppress the disease to some extent. The best ones were Switch and Tyrum, as well as Miravis Prime. Everything you see in the green box it means it's significantly better than the control, which is the red box towards the bottom. Rime is different mode of action as Switch is a DMI, is a group 3 fungicide, and it's up there and look good. So it's an option for rotation. The data we're showing here is you notice it's only for fruit rot incidence. I'm not showing the leaf incidence just because the separation for the fruit, it was better and more clear than the separation for leaf symptoms. We had 2 trials last year. I'm sorry. The second trial was basically we tried to look at many other options for control, but basically the ones that work better were the same that worked well in the first trial, which were Switch and Tyrum. I didn't mention on this previous slide that we look at Bravo and Omega as an option for nurseries, something that maybe the nurseries could use, since those 2 are not registered for fruit growers. But I think we still need to do a lot more here to find fungicides that are effective and work against this, but we're running out of options here. One interesting thing on this second trial here is that where I have the errors, all those products have difenoconazole. Inspire is difenoconazole solo. Quadristop is a mix of difenoconazole and azoxystrobin. Inspire Super is difenoconazole and cyprodenil. And you see the difference where the Inspire by itself or difenoconazole by itself seem to work a lot better than the combinations. So those are Syngenta products, and so Syngenta has used these to apply to a 2EE label to have the Inspire Solo now registered for strawberries and for this disease. So in summary, for the fungicide studies, Switch and Tyrum were the most effective. The DMI fungicides, Rime and Spiro, have also shown some activity, but there are many other groups that don't seem very effective. The SDHIs and all the ones I listed there, as well as the KOI fungicides, we found and confirmed there's resistance present to that group. And Omega and Bravo, as I mentioned, might be an option for nurseries. We've been giving our growers some other recommendations for cultural management, and one of those is for them to avoid harvesting and moving equipment through the fields when the fields are wet. And that's because we see it seems to move very easily from those effective leaves and fruits that you see in the picture. There's just a lot of spores on those tissues, and those spores are very sticky when the plants are wet. So they just attach to equipment and the picker's hands and clothes. And we have seen in many fields where you can basically see a pattern where the equipment has moved the disease from one field to another. As far as the current research that we have going on, one big question we had last year was whether the pathogen was going to be able to survive in between seasons in Florida. And from what we can see at the beginning of the seasons is that unfortunately it looks like it can. It looks like that's exactly what happened, because we're seeing many of the fields that were affected last season have the disease again. What we don't know for sure yet is what is the main place where this is surviving, whether it's it jumped to some alternative hosts around the fields or weeds, whether it's in soil or crop residue. So we're doing a lot of sampling and collection during the season to try to pinpoint that. And that's basically what you see in these pictures here. We've been collecting samples from oak trees, from palms, from reeds. And so those are some of the researchers and my group collecting from oaks and palm trees. And we're hoping that we'll now find in oaks, because if you've been to Florida strawberry fields, it's just beautiful to have all those oak trees around the fields. We're also doing quite a bit of research looking at management strategies. I think we do need fungicides that are maybe more effective, or different chemical groups, because we've been already relying a lot on switch for control of botrytis, colitotrichum, and other diseases. So we do need some fungicides with different modes of action. And I really see that as a short-term solution for the industry. Cultivars are really a long-term solution, but it seems like it's going to take several years before we can get there, considering there's no resistance in the current material. So we're going to have to start from scratch and make crosses. We've been also looking at heat treatment with, if you heard my presentations before, with the plant sauna, or basically a steam. But I consider that only helpful if we're treating plants and planting them in areas where the pathogen is not already established. If we treat and we clean it up and then we put it in fields that have the disease, or nurseries that have the disease, it's not going to be as effective as it should in breaking down that cycle. We're also looking at some strategies that we could maybe use at the end of our season. As you might know, we grow strawberries as an annual crop in Florida. At the end of the season, we kill the crop and we incorporate all that material in the soil. So if it does survive on that crop residue, we need to figure out a way to kill the pathogen on that crop destruct. Bottom line is, I think clean nursery stock is still going to be the key. Even though we're seeing the disease is showing up and moving to fields that had the problem last year, it doesn't seem this year as bad as when it came with the plants, or fields where you can see it came with the plants this year. So I think we should also consider stop movement of plant material from nurseries that have the problem to other nurseries before it gets too late and other nurseries have this problem. So with that, I would like to thank you, my team, and these days of Zoom conferences. That's what we were doing most of the summer. Fortunately, we've been able to get back to our field trials now during the season. But they were really troopers during these hard times and kept working hard and kept smiling. So I'm really thankful for that. And I'm also thankful for the sponsors, and thank you all for listening.